Okay, so let's look at the two new things today, and that is how to stretch it and how to reflect it. What in the equation would do that? Now, I wish we wouldn't have done the moving one. So let's just pretend that this isn't here. Okay, so we cross that out. What I want you to do is just draw y equals x squared. Just do that your best, okay? So we don't need to have it on the side. So that's y equals x squared. Now, if you get your calculator out, I want you to make sure that's in y1. Okay, so in y1 you have y equals x squared. Now, what I'd like you to do now is graph y equals 2x squared. So in y2, with the thick line, go 2x squared. Now, what you'll see is it gets a bit narrower. Now, we call that a vertical stretch. And what I need you to think about is, you know those two ends of the parabola? These here and here? You see these? And do you see there's actually a nail right there? It's nailed in, and what happens is you take the two ends of the graph and you stretch it up. Now, do you see when you stretch it up, it will get narrower. Okay? And if you push down on it, it will get wider. Okay? So that's how we get, that's why we call it a vertical stretch, because I'm actually stretching it vertically. Okay? It's nailed there and I'm stretching it vertically. Now, that's kind of weird. We don't call it stretch like when we squish down on it. That'd be like a squish, right? But we're going to call it a vertical stretch either way. Now, if it's stretched like this, that's when A is greater than 1. Okay? So if A is greater than 1, we get kind of a squish, right? I mean, that's what it looks like if you looked at it from the sides, but we're not really squishing it. So if A is greater than 1, let's not call it a squish. Let's call it narrow. It is narrow, okay? Because I am pulling. Now, if A is between 0 and 1, that's called the proper fraction, like 3/4, 1/2, 2/3, anything like that. It gets wider. Okay? And if you look at the calculator, if I put a y3 as, say, 1/2 x squared, you see I get the wider version now. Okay? So y equals x squared is the middle one. And if I want to get that thing so it gets wider and wider and wider, I would change 1/3. What would you change, or sorry, 1/2. What would you change it to get even wider? 1/3. What? Closer to 0. So 1/9, that's closer to 0, right? And you can see what's going to happen. There's the first one. There's the second one, and there's 1/9. Okay? Because it's getting wider and wider and wider. Okay? So now does everybody see what A does? Now, what would I do to reflect it? Okay, so anyway, let's just finish this. So when you have y equals x squared and y equals ax squared, this is what we would say. It is a vertical stretch by a factor of a about the x-axis. That's what that's always going to be. We did horizontal translation by 4 units right. Well, when it gets stretches, we have to say it's a vertical stretch. Now next year you're going to learn horizontal stretches, but this year you won't. So it's a vertical stretch by a factor of whatever it is, 1/2, 2, 1/3, 1/9, 28. Now 28 is going to be really narrow, right? We always say about the x-axis. Why? That's where it was nailed to. Okay? It was nailed to the x-axis. And it was stretched about it, right? So it's like I'm holding the bottom and I'm just stretching those two ends. I'm just pulling up on them. So maybe I just put them both here and I just stretch and stretch and stretch, okay? So what would I do to reflect it now? Well, if you look at this, okay, I'm just going to actually delete this, this, and this. What if I just put a negative in front? Okay, there's the first one. There's the stretch I did. Now my negative. Okay, so you remember in the homework, it was always minimum, 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 because they were always going up. Now they're going down, so we can have maximums. Okay, because if they're going down, do we know the minimum? No, it's going down and forever. How do I know what the minimum is? You say the minimum, I can tell you one less that it's still going. Okay? But the maximum will be at the very top, because it's not going to get any more than that. They're both going down. So at the very top, when it's going down, will be your maximum. And we're going to look at the y value. The y tells you how high or how low. X does right, left, right? Doesn't help me with that. And we're going to complete a chart later to do that. So, if we put in, so this is, y equals x squared. If I was to reflect this, even on here, that's called a flip. Okay, but it's not supposed to be up there. It's supposed to be right there. Okay? So, we would call that a reflection about the x-axis. A reflection about the x-axis. So you getting all the lingo in your head? Okay? A lot to kind of grasp onto. We got a horizontal translation, 3 units right, and we have a horizontal or vertical stretch by a factor of 4 about the x-axis, and then a reflection about the x-axis. We're going to have to be able to say those for many different questions. Okay? So I want to get right to doing these so you can, actually there's just one other thing that I want to go to 312, the very top. This is the order you will be doing them in all the time, unless they tell you specifically do it in this order. But if you're not told the order, always do it in what I call SRT. Stretches, then reflections, then translations last. Now I know we learned translations first, but you actually do them last when you're doing transformations. Okay? So I've got to think SRT. Okay? If you're a car person, you know that's Dodge's like top kind of racing stuff that they would put on. They call it the Dodge SRT. It stands for Street Racing Team. Okay, so that's how I remember it, the Dodge SRT. But that would be your kind of top level. If you were looking at the Challenger or whatever, the SRT would be the one that they would say, okay, you can take this one on the track. Okay, but you really can't because it's not fast enough. But so we're always going to do them in that order, and unless otherwise indicated. Okay, so this is kind of important Because if they say do this, then this, then this, you can go out of order because they told you to. Okay, so we're going to do A together and then, or A and B together, then after that, we should be good. Okay, so is there any stretches? Yes. So it would be a vertical stretch by a factor of not negative 1/4. How much? By 1/4 about the x-axis. Okay, so let's do that first. A vertical stretch by a factor of 1/4 about the x-axis. So everybody picturing that? A vertical stretch by a factor of 1/4 about the x-axis. Now I'm not done, but what's happening? Can anybody describe what's happening to this picture? It's getting wider. So can you think? Okay, so now you got to do two sides of the brain. Okay, so you got the equation. It says, so if you're thinking of this wider thing now, and then what happens to it after? It gets reflected. Do you have that picture in your mind? So after you say that, then we say a reflection about the x-axis. Or in the x-axis, doesn't matter, about the x-axis. Because it's stapled there again. Okay? Now, do you have a picture of that graph in your head? Because I'm going to show it to you. I want to see if it's the picture you have in your head. Okay? You don't have to do it. You just have to. No, that was my original, right? So let's do negative 1/4 x squared. Okay? Now, do you have the picture in your head? Is it this? Okay? If that's what you had pictured, that means you're using both sides of your brain at one time. Okay? There's the equation, the directions, the analytical, and then there was the visual. Okay? So you have to kind of admit it's kind of cool now that you can actually look at an equation and picture what the graph's going to look like. That's a pretty awesome skill. Okay? One that most of you thought probably was way above what you could do. And next year, you're going to be able to do even more things with it. Okay? But it is kind of neat to know what every one of those numbers does in an equation. Okay, B isn't good because we should, now, it's funny enough, this is kind of what I want it to look like next year, but let's get the A value in the front always, right? Because the A is missing. And it should be Y equals. Now you can have the translation on the left side, but we'll always try and get the, okay, so what am I going to do to get rid of that 1/3? Multiply it by 3. So if I multiply both sides by 3, I would get Y equals 3x plus 6 squared. Okay? So can anybody tell me what happened first then? Yes? Got narrower. I want the actual description. Good. It is a vertical stretch by a factor of 3 about the x-axis. Anything else? Okay, this is what it used to be. This is what it is. We got this, but you see there's a little more information. Yep. Very good. And then a horizontal translation, 6 units left. Okay, so picture that. Okay, you said first it got narrower, and then we moved it 6 units left. Okay, so is your picture okay? Is that what you pictured? Okay. See, it obviously works. Now, when you're doing your quiz or when you're doing your test and you write all the steps down, draw it first. Then go to your calculator and go, yes, that's what I have. Like, do it. You don't have to be all, just go, it's like that, and it's going to be over here. Just do it fast. Then go to your calculator. Hey, I got it right. Look at your description. Does it match your picture? Okay. Now we're going to actually make an equation. We've got y equals x squared. And then we're going to do something. So let's write that down. Y equals x squared. Now they're telling us in a specific order, do this, then this, then this. So now let's start putting up our hands for this because you should know what to do. So I need to make changes in my equation from the words. The first says a reflection in the x-axis. What would this equation look like if I did that? Okay, hands up. Yes. Good. So if this was number 1, which we're going to call number 1, put a number 1 there. If I did number 1, I will get it to be y equals negative x squared. Okay. Next. Followed by a vertical stretch about the x-axis, or by a factor of third about the x-axis. Okay, let's get someone else. What would it now look like? Yes. Good. So after number 2, it will be y equals negative 1/3 x squared. Okay, and then a translation, 7 units right. Okay, so we finished number 2. We're going to do number 3. What would the new equation look like after number 3? Carly? Y equals negative 1/3 x minus 7 squared. Now, what would be the vertex of the new graph? Anyone know? In your mind, have you pictured it? So this is how I do it. See if this is something that you would, okay, that's this. This is this, right? Does that make sense? Then this would be narrow or wide? Wide. And then this would be 7 right. So it's going to be over here somewhere, right? Is that how you're picturing it? Now, what would be the vertex? Seven, 0. Now, here's a question maybe some of you wouldn't get. What is its point 1 comma t? It's on this graph. How would you know what t is, which is actually y? Okay? How do you find t? What is the y value? Yeah? Yeah. take your equation, y equals negative 1/3. Guess what x is? 1. Got that right from the equation. Minus 7 squared. So y equals negative 1/3. Now, brackets, do your work in brackets, that's negative 6 squared. Okay? What's negative 6 squared? 36. Negative 1/3 of 36. Negative 12. So it is 0.1 negative 12. Okay. So the last thing we're going to do is this equation. Now let's do a visual of this equation, because if you do the visual, I think these make a lot more sense. But that's just me, because I'm a visual person. Okay? I see a picture, it's like, oh, okay, yeah, I get it. But if you're just like talking to me, it's like blah, 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 and then a word in there like vertex. Oh yeah, I remember that word. Blah, 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 okay? So, first of all, I started with y equals x squared. So that's where I started. So that's starting. Now, what do you think happened next? Is there a stretch? No. Okay, so next would have been a reflection. Okay, so I did my negative. Okay, then what would have happened? Okay, then I got to go 3 to the left. Okay, so I'm going 3 to the left, and see, the negative 4 should come to the other side, right? To be y plus 4. So what does that mean? Y plus 4. 4 units down. So I got to go 3 left, 4 down. So that's negative 3, and I'm down negative 4. So this is what my graph should look like. Does that make sense? Okay, so all I'm doing is deciphering a mathematical equation to do all this. But, you know, after I get a picture, you're going to see how easy these are. What would the vertex be, do you think? Negative 3, negative 4. Okay? Max or min? So max. What value? Like, what is the maximum value? Now, we're always looking for the y value, because that does up, down. Yep. Negative 4. Axis of symmetry. X equals negative 3. Good. What's the domain? Oh, the diploma loves domain range, domain range, domain range. They must say that like 30 times on the... They may not ask for it all the time, but they're always talking about domain range. Okay? What would be the domain of this graph? All the reals, right? It's going forever and ever in both directions. So x in the reals. What about the range? What would it be? I haven't heard the right answer yet. It's got to be less than or equal to negative 4. And y's in the reals. Okay. Now, I want to do one question in the homework. It's quick. Just go to number 1D. Now, number 1D, the reason I'm going through it is because last year, students weren't quite doing the math right. What? I want to get the 2 on the other side, right? Just like we did in that that other question, but that other question didn't have that 12 over there. So you're going to divide by 2, right? Make sure you divide this entire side by 2. This is very, very important, because if you just divide the one term and leave the 12 over there, you're going to get the wrong answer. So this is actually y equals 1/2 x minus 8 plus 6. And then you can bring it over to the other side. Okay? So it's important you divide both terms. Whenever you divide, you have to do every term. And there isn't one like this in the notes, right? So I put it in the homework. I've already done one-year questions. Okay? So, not only is it pretty understandable, I'm even going to give you just questions 1 to 7. So, probably all of you will finish in class. I caution you, though, this quiz will be hard to impossible on Monday if you don't make a couple little notes on a study sheet so you have it out next class. Okay? So after you finish your homework, we're not talking. Okay? Because there's still a couple people that need to finish. I need all 6s from all of you and a study sheet done by all of you. And Monday will go better. I know it's awesome because Friday will be that much nicer if you don't do a study sheet. But it won't be that much nicer. But Monday will be way better if you do a study sheet. So we've got to be thinking about Monday a little bit.